Okay, so moving to the last advanced topic, which is your integration by parts. So I think the advanced technique that you're going to use here is you must have a knowledge of partial fractions. So if wala mo concept partial fractions, so I think it will be difficult for you to integrate the following equations. Okay. So usually in the previous curriculum, so since partial fractions was introduced in advanced algebra course, so marag it's easy for us to go through this particular topic. But since in your case, I don't know if you have discussed partial fraction decomposition, so I think it's difficult for some of you who don't know how to deal with partial fractions. Okay, so the factor in the denominator, so as you can see in the left column, and the partial fraction decomposition for which is this term here, a over ax plus b. So what do you mean by the factor in the denominator? So for example, the format of your equation is, let's say, x all over ax plus b, di ba? Or let's say this one is just 3. Okay, so other examples for this one is, let's say, 3 all over 3x plus 4. So the corresponding partial term for this one, partial fraction for this one is, ha? Oh, no. Oh, nakuha ko de. Sige. Na-out man ito kanina. Sige. Okay, so muna siya so makita na ng slide, oh? So muna siya on the left side is your partial factor. So meaning those are the terms found in the denominator. And then the corresponding partial fraction decomposition are the terms on the right side, on the right column. So we have different formats for your factors in the denominator. So we have ax plus b, and then your ax plus b raised to the power of n. So it could be any exponent. And then the corresponding is partial fraction is also this one. So it's the same as the previous one, but it's only repeating up until to the power of n, as you can see here. Okay, then we have quadratic, which gives us this partial fraction, and we have also a repeated version of your quadratic equation, which gives us the same partial fraction as the third line, but since it's repeating, so it's only up until the power of n. So take note that your a, b, c, and d are your constant values, are your constants, so those are numbers only. So how we are going to deal with this one is, again, I think the long version for this one is just on how to deal with the partial fraction first, and then the integration later will be easy because most of the answers of your partial fractions are in natural logarithmic or in ln, because we'll be having a over something, a over x plus 3, so those fractions gives us the ln integrals. So if you want to search this online on how to deal with partial fractions, so most likely the name of the terms that you're going to find in the internet or in other references, so this one is distinct linear factor, the first line. That's how you call it, distinct linear factor. That's the factor in the denominator. So why do we say it's distinct linear factor? Because in the denominator you can have as many as different linear factors that you can have. So it could be that you have 1 all over x plus 1 times x plus 2. So these two are different. That's why it's distinct. One is unique from the other. Okay, so next is your repeated linear factor. So it's repeated because again the linear factor is being repeated, raised to the power of n. So repeated linear factor. So the third one is what you call as your distinct quadratic factor. So as you can see in the equation, that's ax squared. So that's quadratic. So again, you can have as many as many distinct quadratic factors that can be found in the denominator. And then lastly is your repeated quadratic factor. So the same as your second line. So the quadratic equation is being repeated to the nth term here. Okay. So again, if the equations here are just for, this will be our guide later on. So as you can see, for the distinct linear factors and distinct quadratic factors, so it only shows one term. But for example, you're having two distinct linear factors, so you can add up again another one. So that will be b plus ax plus b. Or if you have three distinct linear factors, you can add another one, c all over ax plus b. Same goes for your quadratic. So for example, you have two distinct quadratic factors. So this becomes cx plus d all over ax plus bx plus c. So it will depend on how many terms you're going to have in the denominator. So of course, another technique that you need to master here is you know how to factor out algebraic equations or simplify them into factors. So factoring, so you have difference of two squares, perfect square binomial, perfect square trinomial, perfect cube trinomial. So you're going to have to go back to those topics because you'll be needing it in this particular technique. Okay, so since you don't yet understand what this fully looks like, so let's go to the examples. So of course we'll just be solving 4 examples because I think solving 4 equations is already long. So before we solve, so in partial fractions, so how can you know that you're going to use partial fractions? So upon looking at the equations given in the slide, so observing that the numerator is always lesser degree than the denominator. So for example, in the numerator in number 1, so the degree of the variable is only to the power of 1. Then in the denominator, it's second degree. So that's the time that you can say that you're going to use partial fractions because the degree in the denominator is higher compared to the numerator. Okay, so in number 2, so cube against cube, but it's not cube, but it's to the power of 4 because 1 then 3. Okay, so you have fourth degree in the denominator because you have cube plus the other variable here against third degree equation. So you can use partial fraction. So for number 3, that's third degree against second degree equation. So you can use partial fraction for this one. So also for the for the fourth one, so third degree against fifth degree. So fifth, so this one is to the power of 1. Then this one is to the fourth, right? So fifth against third. And the number 1 is second against first degree. So notice that the degree in the denominator is always bigger compared with the numerator. So if you have this condition in your equation, in your integral equation, so that's the time that you're going to use partial fractions. So most likely, I think in my experience, these um, equations are in the difficult numbers. So usually test 3, so before, but I don't know if it's included in the exam because it's a difficult topic. Alright, so let's try to go to number 1 so that we can fully understand the process of partial fraction. Okay, so let's go to the integral of 2x plus 11 all over x squared plus 5x plus 6. So since we already know that we need to use partial fraction because the denominator is of bigger degree compared with the numerator. So what we need to do first is we need to evaluate the denominator by getting its factors. So this one. So let's try to evaluate this one by getting the different factors. So again, thanks to the knowledge of algebra, so we can break this down into two binomials. So this one is x plus 3 and then x plus 2. So I think that's the super basic concept, diba? Because if you want to multiply them again, I think the value is also the same here. So if you want to verify, so you're going to use FOIL method. So first term, outer term, then inner term, then last term. Okay, so upon observation of the factors, so you have two distinct linear factors, diba? You have two distinct linear factors. So let's try to change color first. So let's ignore first the integral symbol because we want to evaluate the partial fraction first. So we have 2x plus 11 all over x squared. So instead of x squared plus 5 plus, I can also do that in the left side, but I think it's better if you make it in factors already. So instead of x squared plus 5, x plus 6, so you can have x plus 3, then x plus 2, then equals, so that's how you write your partial fraction. So the first one is, again, since that both are distinct factors, so you're going to have a all over x plus 3 plus b all over x plus 2. So that's how you write your first step. So again, we have determined that we have two distinct linear factors. So again, distinct linear factors. So again, as per formula, that will be a all over the particular factor. So distinct linear factor. So again, for those of you who have forgotten the formula was presented in the last slide, so that will be a all over ax plus b. So since we have two distinct linear factors, so that's why we repeated it again and then copied the second distinct linear factor. So the next step is for us to solve a and b constants. So we need to solve a, we need to solve b as well. So you're going to have two unknowns here. So how do we do that? So let's multiply everything first with the LCD. Or let's say we multiply everything by this term here. So x plus 3, then x plus 2. So the equation becomes 2x plus 11 because it automatically eliminates the denominator. Then you have a, so multiplied by x plus 3 times x plus 2. So this becomes x plus 2. And then plus b. Then this becomes x plus 3. Okay. So this is the time that we're going to have one line of equation. So upon reaching this point, so we're going to have two methods on how to solve a and b. So the first one, so let me write it in another color. So para makulay sa buhay. Kanilang na. So the first method is what we call as elimination. So by elimination. So what's the process for this one? So we let x be equal to something so that we can eliminate one variable, let's say a, and then, or if you want to eliminate b, so you let x be equal to something so we can solve one variable. Okay, so let's say we want to eliminate b. So if we want to eliminate b at x is equal to negative 3. So upon looking at the term b here, so if you want to eliminate b, so the value of x must be negative 3 because negative 3 plus 3 is 0. And 0 times b is 0. So that's why, ano siya? So trying to eliminate b. Okay, so of course, if letting x be equal to negative 3, so it also applies to the other x parameters in the equation. Okay, so for example, letting x be equal to negative 3, so we have 2 times negative 3 plus 11 is equal to a times negative 3 plus 2. So again, if we try to write b on the b still, so this becomes 0. So what's left in the equation is we have negative 6 plus 11, then a times negative 1 plus 0. And your a value is, you have 5 is equal to negative a, and then a is equal to negative 5. So that's the first one. So you now have a is equal to negative 5. So the next step is for us to eliminate a next. So to eliminate a, so at x is equal to, so again, if you want to eliminate a, so the x value must be negative 2. So again, it also applies to the different values of x. So we have 2 times negative 2 plus 11. Then that's a times negative 2 plus 2. Then plus b times negative 2 plus 3. So this becomes 0. So what's left in the equation is we have negative 4 plus 11 is equal to b times 1. Okay, or just b. So your b is equal to 7. Okay, so that's the first method. So let's try to verify this one with the second method. So I think both methods have pros and cons, so I'll discuss it later. So let's try to solve the second variable. The second process. Okay, so let's try it in the next slide. So we have 2x plus 11 is equal to a times x plus 3, then x plus 2, then plus b times x plus 3. So the second method is what we call as equating coefficients. So I think for me this is the best method that you have to use, because even though it's a long process, I think the answer is sure, and you have confidence that your answer is correct comparing it with elimination method, because elimination method is only good for two unknowns, let's say a and b only. So what if your unknown is up until d, so that would be a difficult one for you to handle. So by equating coefficients, so what we need to do here is we need to expand fully the equation. So we have 2x plus 11 is equal to, so again, expanding it. So we have ax plus 2a, that's coming from the first term. Then bx plus 3b. Okay. So next step is we need to group together the same terms. So grouping together the x terms and grouping together the constant terms. So what we're going to have is we have 2x plus 11 is equal to ax plus b x, then plus 2a plus 3b. So for us to be able to determine that it's the same as the left side, so we have 2x here. So the right side must be also in coefficient x. Then we group together also the constants. So what they mean by what I said earlier is we have 2x plus 11. So for us to follow the format of 2x, so we have to factor out x. So this becomes a plus b times x. Okay? And then we group together also the constant terms, 2a plus 3b. So the next step is for us to equate coefficients. So that's why we have the title as Equating Coefficients. So the coefficient of x, that's 2, against the coefficient of x on the right side, that's a plus b. So we have 2 is equal to a plus b. Okay, so how do you write that properly? So you can write it in this manner. So that's the x parameter, then semicolon, so that you know that this one is coming from the x coefficient. Okay, so next is the constant coefficient. So this becomes c semicolon constant coefficient. So this becomes 11 is equal to 2a plus 3b. Okay, so looking at your equations, so you have two equations. And by algebra, since you have two unknowns, so you need two equations. So we have the correct solution here. Okay, so next is if you have forgotten how to solve two equations, two unknowns in your algebra, so let's try to review some of the techniques here. So you can use elimination or by substitution. Diba? So by elimination is you multiply a certain value so that you can eliminate one parameter. So let's say negative 2. So this becomes negative 4. This becomes negative 2a. This becomes negative 2b. So by adding them up, so you have 7 is equal to 0 plus b. So b is equal to 7. And then let's say you're going to use equation number 1. So using equation 1, so we have 2 is equal to a plus 7. So a is equal to negative 5. So notice that we have the same answer as the previous slide. Okay, so that's by elimination. So if you want to use substitution, so using equation 1 to 2, so let's say you want to create it in this format. So let's say you want to replace a. So you have 2 minus b is equal to a. And then plug it in the second equation. So you have 11 is equal to 2 minus b plus 3b. Sakto ba? Okay, so this becomes, so I think it's wrong siguro. So 2 minus b is equal to a. So this one is 2 there, 2. So this becomes 4 minus 2b plus 3b. So it's also 7 is equal to b. Then repeat the same process. So that's the two ways in determining your values of your a and your b. Okay, so one is elimination, and then the second one is equating coefficients. So I think the advantage of the elimination is if you only have two unknowns, let's say a and b, because you can eliminate one and have one unknown in the equation to be solved. But if you have more than two unknown equations, so I think the best way for you to do is to use equating coefficients. So even though it's a long process, so I think the answer is sure. Okay, so let's try to solve the equation. So number 1 pa, no? Taas na kayo. So the equation earlier becomes in this term here. So we have negative 5 because that's a over something all over x plus 3 plus 7 all over x plus 2 dx. Okay, so looking at the two terms, so it's easy for us to say that the integral is of the ln degree. So if you want to replace the two terms so that the negative sign is on the right side, so you can also have it in this manner. So this becomes 7 all over x plus 2 minus 5 all over x plus 3 dx. Okay, so again, if you want to verify that you want that you will be having ln as your integral, so let's try using u sub. So u is equal to x plus 2. So du is equal to dx. So same as this one. This one is u is equal to x plus 3. Du is equal to dx. Okay, so we're going to have a 7 integral of du over u here. Then the other one is negative 5 integral of du over u. So as you can see, you have ln as your answers. So you have 7 ln of x plus 2 minus 5 ln x, x plus 3 plus c. So this is the final answer. So as you notice, the integration part is super simple, but getting the corresponding partial fraction is a long process, diba? Kung tanaw na to. Okay. So do you have questions? So I think there's no question. So I hope that you know how to solve partial fractions in two methods. So again, I suggest that you have to use equating coefficients because that's the easier process for me. So again, elimination is only best if you have two unknowns. Okay, so let's proceed with the next example. So looking at your equation, so the denominator can be fully factored into this equation. So you have x. So as you can see, you have repeated, diba? Repeated. You have 3x plus 1. Okay, so repeated. And you have one distinct linear factor. So again, writing it in partial fractions first, ignoring first the integral symbol. So we have x cubed minus 1 all over x, then x plus 1 cubed. Okay, so we have the first one is a all over x. That's the first distinct linear factor. Then the next three terms are repeating. So starting off with the first one, b all over x plus 1 plus c all over x plus 1 squared plus d all over x plus 1 cubed. Okay, so multiplying everything with the LCD, or let's say the denominator on the left side, that's x times x plus 1 cubed. So we're going to have x minus x cubed minus 1 is equal to a times x plus 1 cubed plus b times x, then x plus 1 squared plus c times x plus 1, then plus d times x. So notice we have four unknown constants, a, b, c, and d. So difficult na siya, diba, if we're going to use elimination. So if you're going to use x is equal to negative 1, so what remains is only the d parameter. Diba? Then how about the 4? So I think if you're going to look at the equation, it's really difficult for us to use elimination. Okay, so I'm going to write it here. So by equating coefficients, Okay. So again, we need to expand the terms here. So this one is x cubed. So notice that x cubed going to -1. So we still need the square values. So how do we do that? Is we try to write imaginary values. So that will be 0x squared minus 0x minus 1. So 0x squared is still 0, minus 0x is still 0, minus 1. So why do we need to put this one? So it will be important later as we go along with the process of equating coefficients, because we'll be needing the coefficients of your x squared and the x variables. Okay, so expanding the first term, so this will be x plus 1 cubed. So how do we expand that one? So of course, if you know the shortcut from algebra, so this is x cubed plus, so I don't know if I'm correct with this one. So x cubed plus 3x squared, I don't know if I'm correct. So tuloy manual para sure. So x squared plus 2x plus 1. Then multiply it with x plus 1. So x cubed plus 2x plus x. And then x squared, 2x squared plus 2x plus 1. Sakto lagi. Then 3x plus 1. Okay. Then next is your b. So we have b times, so that will be x cubed plus 2x squared plus x. Okay, so ako lang siyang i-shortcut. Then x squared plus x, then plus dx. Okay? So atong tarong ko suwat kay para makita ninyo. So on the left side, that will be x cubed is equal minus 0x squared minus 0x minus 1. So expanding the term, ax cubed plus 3ax squared plus 3ax plus a. Then bx cubed plus 2bx squared plus bx plus cx squared plus cx plus dx. So by this time, we can now equate coefficients because it's fully expanded. So we can group together immediately the terms. So para di tayo maglibog, so let's try to group them by degree first. So cube first, so a cube, b cube, and then there's no c or d cube terms. So this becomes a plus b, and then x cubed. Okay. So next are the squared terms. Squared, 3a x squared, 2b x squared, cx squared. So there's no dx squared. So plus 3a plus 2b plus c x squared. So next are the x terms. So 3ax, bx, cx, and then dx. So you have 3a plus b plus c plus d times x. And then lastly is the constant term, which is your a. Okay, so by equating coefficients, so again, cube first. So this is x cubed. Now semicolon. So that will be 1. That's the coefficient of x cubed on the left side is equal to a plus b. Okay, so next is your x squared. X squared. So that is 0 is equal to 3a plus 2b plus c. So next is the x term. So that will be 0 is equal to 3a plus b plus c plus d. And then lastly is your constant. That will be negative 1, then a. Okay, negative 1, and then a. So I forgot to place the different values on the left side. Okay, so as you can see, we have already solved one variable. Okay, so looking at your equations, so I think you can simply solve the other variables by using other equations here. So let's say this one is equation 1, equation 2, equation 3, and then equation number 4. So observing the 4 equations, we have solved already A. So by using equation number 1, equation number 1 here. So I'm going to write it as 4 to 1. So meaning equation 4 to 1. So that will be 1 is equal to negative 1 plus b. So transposing b is equal to 2. Okay. So we now have 1b here. You also have negative 1 as your a. So next is using equation 3 next. I mean equation 2. So equation 2. So that will be 0 is equal to 3 times negative 1 plus 2 times 2 plus c. So c is equal to, so 4 minus 3, that's 1. Then we have negative 1 for your c. Okay, so lastly is your d. So using equation 3, so ako lang i-singit lang dali, equation 3. So this is 0 is equal to 3 times negative 1 plus 2 plus negative 1 plus d. So d is equal to, so negative 3, negative 4, negative 2, so d is equal to 2. Okay, so do you have questions so far? So I think there's no question. Okay, so let's try to solve next the integral. So ito sang i-read balik. So the equation from the form of x cubed minus 1 all over x times x plus 1 cube. So it becomes, so a as negative 1. So the first term is negative 1 all over x plus b. So our b is 2. So that's positive 2 all over the first x plus 1 term plus the second one. So we have negative 1. So instead of plus, this is minus. So minus 1 all over the second term, which is x plus 1 squared. Then the last term is 2. So you have 2 all over x plus 1 cubed dx. Okay, so if we try to integrate this one individually, so this becomes negative ln, di ba? Para makita ninyo, let's try to use another color. So this one is we let u is equal to x, and then du is equal to dx. So we have the integral of negative du over u, di ba? That's the first term. The second term is let u is equal to x plus 1. Then du is still dx. So the integral becomes 2 integral of du over u. So for the third one, still the same. U is equal to x plus 1, then du is dx. So this becomes negative du all over u squared. Or we can make this as u to the power of negative 2 du. Diba? So dili siya ln always. So you have to verify it as much as you can. Okay, usually the shortcut will lead us to the wrong answer. So this one is 2 integral of du all over u cubed, or this becomes 2 integral of u to the power of negative 3 du. Okay? So giving us the answer, so we have negative ln of x, so plus 2 ln of x plus 1, then minus, so looking at this term here, so we have negative 2, so plus 1, diba? So 2u, then negative 1 all over negative 1, then plus 2, di ba siya 2 there? So it's only, yay ka, napapas man tayo noon. Sige, ato lang sa aton balik. Okay, so negative ln of, so ato lang sa EU ha para makita na to. Then plus 2 ln of u. Then minus u to the power of negative 1 because negative 2 plus 1, then negative 1 plus 2 times u to the power of negative 2 all over negative 2. Then plus c. So final answer is negative ln. So the first u here is x, so ln of x plus 2 ln of, so the u here is x plus 1, then plus instead of minus because minus minus, this becomes 1 all over x plus 1. Okay, and then the minus, then plus, so that's minus 4 all over x plus 1 squared plus c. So this is the final answer. Okay, so questions, clarifications, o violent reactions, kay lisod na siya. So mo na siya, di ba mo naglisod siya because again, if you don't have this topic, kaning partial fraction, kay mo naglisod jud siya i-comprehend. Pero mula na yung bata ng sa akong yatag nga kuan. So I think you can review this one in the recordings at later. You can follow the process. So since I'll be giving you the problem set also, so ang kaning problem set ani is ako lang sigurong i-way past deadline because it's really difficult jud. Yeah. Upon solving the different partial fractions, so try to follow the recording as well para namoy guide ba. Okay? So normal na nga dili kasabot kay sa una sa diso kasabot ani nga topic. Makasabot ko gamay because we have partial fractions before, but even though nga namin partial fractions before, so naglisod sa ko remember sad. Okay, so I think let's try to solve the kaning quadratic equation, because I think we we don't have to go to the degree of repeated quadratic. It's too much na pud. And I don't think the examiner will give you repeated quadratic as a problem. Because as far as I have experienced the exams of the EM coordinator, so puro siya sa yun jud. Mara ako ra siguro lisod na. Okay, so let's go to number 3. So din na taman, we have to deal with quadratic lang na, not repeated quadratic. So again, we can factor this one out. So x times x squared plus 2x plus 5. Okay, so notice that one is distinct linear factor, the other one is distinct quadratic. So as you can see, it's quadratic because we cannot further simplify x squared plus 2x plus 5 into its corresponding factors. Diba? Okay. The factor for 5 is 5 plus 1 naman. Then the middle term is plus 2x. Okay, so what we're going to have here is x squared. So writing the plus 4x plus 10 all over x cubed. So instead of x cubed plus 2x squared plus 5x, this becomes x times x squared plus 2x plus 5. Okay, so the first term is only a over x, and then the next term is bx plus c, because we are now dealing with a quadratic factor. So this is x squared plus 2x plus 5. Okay, so multiplying everything with the denominator on the left side of the equation, that's x times x squared plus 2x plus 5. So we have x squared plus 4x plus 10 is equal to a times x squared plus 2x plus 5. So I think in this process, follow pa mo, diba? Kaya we are just multiplying the LCD, bx plus c, then times x. Okay? Okay, so again, the best way to use here is equating coefficients because we have three unknowns, a, b, and c. So again, the unknown parameters here are, sorry, are a, b, and c. Okay, a, b, and then c. Okay, so again, by equating coefficients, so again, if you refer this one in the first example, we have two methods. We have elimination and the other one is equating coefficients. Okay, so expanding the terms, so this will be x squared plus 4x plus 10 is equal to, again expanding, ax squared plus 2ax plus 5a, then plus bx squared plus cx. Okay, so grouping together the x squared variable, so x squared, x squared, so you have a plus b x squared, then plus, next is the x terms, so that will be 2a plus c, then times x. Then lastly is the constant, since here is a plus 5a. So again, equating coefficients starting with x squared, x squared. So x squared is 1, 1 as the coefficient on the left side is equal to a plus b. So next is the x variable, so x and then semicolon. So the coefficient on the left side is 4, on the right side that's 2a plus c. Then lastly is the constant. So you now have 10 on the left side is equal to 5a. So we have three unknowns, three equations. So as you can see in the third equation, so in equation number 3, so this becomes a is equal to 2, di ba? So we now have the first one, okay, coming from this equation, divided by 5. So 10 divided by 5 is 2. So next is, so using equation 1, so that will be 1 is equal to, so a is 2 plus b. So b is equal to negative 1. Lastly is using equation 2. So using equation 2, so we will have 4 is equal to 2 times 2, then plus c. Diba? So c is 0. Okay? So getting the solution in the new form of the integral, so going back to the red color, so we have the integral of, so that will be 2 over x then minus b, that's negative 1, ba? Then plus 0, Atong ikaw na para makakita mo gin sa to. So this is a over x plus bx plus c all over x squared plus 2x plus 5. Diba? Dapat pa na siyang new format niya. So our a is 2. So this becomes 2 all over x. Then plus, so bx plus c. So this is negative x plus 0 all over x squared plus 2x plus 5. Okay. So simplifying further is we have 2x, 2 over x minus, so minus because we can incorporate this one here, negative x all over x squared plus 2x plus 5 dx. Okay, so how do we go about this integral? So again, if you want to solve this one, so let u be equal to x, and then du is equal to dx. So the first one is 2 integral of du all over u. So this becomes ln. So how about the second one? So if you know how to integrate already by focusing on this term, so u is equal to x squared plus 2x plus 5. Then the derivative of this one is du is equal to 2x squared plus 2, di ba? Plus 0 dx. So notice that the numerator is of a different term. So what you need to do here is we're going to have to complete the square in the denominator. So I think it's an advanced technique also. So since we cannot use u sub here because we have no 2x plus 2 in the numerator, so what we're going to do here is we're going to complete the square in the denominator. Okay, so borrowing, let's say, 1, di ba? So, akong pasabotan na niya is may mo siya inani. So, x squared plus 2x plus 4 plus 1 na, di ba? Because 4 plus 1 is still 5. So, this term here can be grouped together. This becomes x plus, sakto ba? X plus, sayop tayo, sayop. Bali. So 2x plus 1, then plus 4. Okay? So this term here becomes x plus 1 squared, and then this becomes plus 4. Diba? So I think you are familiar with this term here. Diba? So maragmay mo siyang katong arctangent na kuan, di ba? Or you can also use this one as your u sub. So let u be equal to x plus 1 dito siya pwede dahil. Okay. Okay, so let's try to figure out. So hasta ko nabagtang sa gutong sa lisod. So atong ikuha na. So x all over x squared plus 2x plus 5 to no? So tatanawon sa ikon niya ato sang i-observe. So pwede din siya u sub day, u sub. Okay. Sa so the equation becomes minus x all over x plus 1 squared plus 4 dx. So you can use u sub. So you let u be equal to x plus 1. And then this becomes u squared, and then the numerator becomes so x is equal to u minus 1. Ana. Okay, so ang du ano niya is still dx. So if you try to transform this one again, so this one becomes the integral of, so minus integral of u minus 1. Then you have u squared plus 4 dx. So ana de siya day. Okay, then next is, since this one is a binomial in the numerator, so you can expand this one into this format. So u all over u squared plus 4. And then plus, minus tayo, minus. Iyay ka, nawara sa siya. So lisod na siya, no? Lisod. Basta ako lisod sa siya para na ako. Then 1 all over u squared plus 4 dx. So for the u all over u squared plus 4, so I think you can let u be equal to, you can now use u sub. So ang kaning first term here is you can use u sub because so ato lang is z lang, okay, since we are using u now. So let z be equal to u squared plus 4. So dz is equal to 2u du. Okay, then on the right side, since that's u squared plus 4, so that becomes arctangent integral, di ba? A squared plus u squared, di ba? So just try to kuan lang siguro ni kay murag naggubot na ako ang solusyon. So 2 ln of x, and then on the right integral, so this becomes minus the integral of 2u du, diba? And then di siya 2u du day. So this becomes dz over 2 day all over z, then minus, and this one is integral of plus day, plus na because minus, then minus, and integral of du all over u squared plus 4. 2 ln x, and then you have 2 ni siya, minus 1/2 ln of a z, then plus arctangent u over 2 plus c. So i-follow lang ninyo, asa ko na nawagtang kay Kung atong ibalik kay masin malapas ta og 12 ka pin. Okay, so 1/2 ln of z. So our z is u squared plus 4. Then plus arctangent. So u parameter is pila sa may u parameter na to. X plus 1 all over 2 plus c. So final answer is 2 ln x minus 1/2 ln of x squared plus 2x plus 5, and then plus arctangent x plus 1 over 2 plus c. Na, so managwa na ko tarong ang answer kay ang gitarong siya answer but walang natarong og suwat kay managbati na kita na. Okay, so basin na overwhelm mo sa topic, so just try to review the recording later. Basta I think what I can suggest to you is you have to at least master the distinct linear and the repeated linear, because for sure one problem will come out in the exam for partial fractions. So I think at least distinct linear and repeated linear. I think example number 1 and 2 lang. Okay? So kanisha is just for extra siya. I think you know how to solve quadratic partial fractions. Okay, do you have questions? Or managway question no kay Libog? Oh, sige.